This video will talk about mapping figures onto themselves. We usually see transformations where a shape is moved from one place on the plane to another. For example, this reflection of the trapezoid over the y-axis. But what happens if the line of reflection lies on top of the figure? What would the reflection of the trapezoid over the line look like now? Perform the reflection the same way. First, label the vertices. Start with vertex A. Find the distance to the line of reflection and then travel the same distance on the other side to place the reflected point. Notice A' ends up on top of point B, and D' ends up on top of point C. Now try reflecting the points B and C. B' ends up on top of point A, and C' lands on top of point D. Connect the new points. Notice that the image lies directly on top of the pre-image. In fact, this reflection mapped the figure directly onto itself. The reason this worked is because the line of reflection is also a line of symmetry for the figure. But what if the line of reflection is on top of the figure, but not along one of the lines of symmetry? If you reflect this figure over the line, the image overlaps the pre-image, but it does not map directly onto itself. As a rule, if the line of reflection lies on top of the line of symmetry, the figure will map onto itself after the reflection. Notice this square can map to itself in a number of ways. A reflection over this line would map it to itself because it's a line of symmetry, as well as this line. The square has lines of symmetry across the diagonals as well. So reflections along these lines would map the figure to itself. This figure has 4 lines of reflectional symmetry. But does it have rotational symmetry? Rotational symmetry means that you can turn a figure about a point so that it lands exactly on top of itself. To rotate this square so that it could land onto itself, the center of rotation would have to be at the center of the figure. The best way to find the lines of rotational symmetry for the square are to draw lines from the center of rotation to each of the vertices. Each angle is 90 degrees, and watch what happens when you rotate the figure 90 degrees. It maps onto itself. This is true for all of the angles. So rotation of 90 degrees, 180 degrees, 270 degrees, and 360 degrees would map this figure onto itself. Try the following problem. A triangle is shown. Which of the following transformations about a point or line map the triangle onto itself? Try performing the transformations. The first one, a reflection about the x-axis, would result in the following image. The triangles overlap, but the image is not mapped onto the pre-image, so this is not the correct option. How about the next one? A reflection about the line x equals 6 results in the following image. Notice that the line of reflection is also a line of symmetry, which is why this triangle got mapped to itself after the reflection. Try the next one. A rotation of 90 degrees about point 3, -2. If the point 3, -2 is the center of rotation, a rotation of 90 degrees would transform the image to here. So this transformation does not map the triangle to itself. Try the last one. A rotation of 360 degrees about the point 6, 0. A rotation of 360 degrees would be a complete turn around the point. This would map the triangle back onto itself. So this transformation works as well. Try one more problem. A parallelogram is shown. Which sequence of transformation maps parallelogram ABCD onto itself? Try the first one. A reflection over the x-axis would transform the image like this, followed by a reflection over the line y equals x, which would transform the image like this. Notice this combination of transformations does not map the parallelogram onto itself. How about the next one? A reflection over the line y equals x, followed by a reflection over the y-axis. Unfortunately, this does not map the figure onto itself either. How about the third option? A reflection over the x-axis, followed by a reflection over the y-axis. Notice the image of the second transformation lies on top of the original figure. Therefore, a reflection over the x-axis followed by a reflection over the y-axis results in a sequence that maps the parallelogram onto itself. Quickly check the last option just to be sure you have the right answer. A reflection over the line y equals x, followed by a reflection over the x-axis. You can see that this sequence of transformations does not map the parallelogram onto itself. With these problems, the shape of the figure makes a difference. If this had been a square, then all of these answers would have been true. In review, if the line of reflection lies on top of a line of symmetry, the figure will map onto itself after the reflection. The same holds true if a figure is rotated from one line of rotational symmetry to the next. Happy solving!